Tool is being unleashed in Florida's Everglades to hunt Burmese pythons. All right, take a look at this right here. Scientists have deployed 120 robot rabbits.
When Florida released hundreds of robotic rabbits into the Everglades, officials believed they had finally found a way to outsmart the invasive Burmese pythons, destroying the state's wildlife.
Anacondas and pythons and shit. Mostly pythons in Florida.
God damn.
Yeah, they're giant. And they're infested. They're 17, 18 feet long.
Anacondas or pythons?
Pythons.
Shit.
The plan was simple. The fake rabbits would lure the snakes into traps and end a crisis that had lasted for decades. But within weeks, strange footage and unexplained data began to surface.
Florida is deploying robotic rabbits to help capture invasive Burmese pythons in the Everglades.
What the scientists discovered next left them questioning whether they had solved the problem or created a monster. The Everglades nightmare: how Florida became a snake kingdom. At first glance, the Florida Everglades appear vast and untouched. The area is a massive stretch of wetland filled with shallow water, tall grass, and scattered islands of trees that seem to extend endlessly across the landscape. But beneath the surface, something unnatural has taken over. Hunters and biologists who walk the wetlands say the silence is the most terrifying part. No rabbits, no birds, no rustle in the grass. It is a graveyard of what used to be one of the richest ecosystems in America. The cause of that silence is the Burmese python, a predator that should never have been here in the first place. In the 1980s and 1990s, the Burmese python became one of the most popular exotic pets in the United States. Pet stores and shopping malls sold them for less than $30. People bought the tiny hatchlings without realizing how enormous and dangerous they would become. Within a few years, those snakes grew over 15 feet long and were capable of killing large animals by constriction. Many owners released them into canals and swamps once they became impossible to manage. Then in 1992, Hurricane Andrew tore through South Florida and destroyed entire reptile breeding facilities. Thousands of adult Burmese pythons escaped into the wild and began breeding in the open wetlands. With no natural predators and plenty of prey, they multiplied quickly and spread through the Everglades. Scientists later called that event the biological Chernobyl of Florida because it permanently changed the ecosystem. Within less than 2 decades, the Everglades turned from a balanced wetland into a territory dominated by snakes. The pythons became top predators and started wiping out nearly every small and mid-sized animal they could find. Native mammals began disappearing faster than researchers could record the losses. Studies by the U.S. Geological Survey found that raccoon and opossum populations had dropped by more than 90% in certain regions. The marsh rabbit, a small and vital prey species, vanished completely in many areas by 2010 because pythons hunted them relentlessly. Even larger animals such as deer and foxes were discovered inside the stomachs of captured snakes. Footage from government necropsies showed scenes so disturbing that some parts were withheld from the public. In one case, scientists recorded a python that had torn itself open while trying to swallow a 6-foot alligator, its ribs split apart and the reptile still visible inside. Another dissection revealed the remains of a full-grown deer, its hooves and skull emerging from the stomach of an 11-foot snake. The invasion also crippled local agriculture. Farmers living on the swamp's edge began losing calves and goats from fenced pastures. Torn wire and scattered remains were the only signs left behind. As small mammals vanished, mosquito populations exploded. Those mosquitoes carried diseases like West Nile virus and Eastern equine encephalitis, spreading sickness through both rural communities and livestock. Even Florida's waterways began to suffer. During floods, piles of python carcasses clogged drainage canals, worsening runoff that already carried fertilizers and animal waste into nearby farms. Every part of the system was unraveling. To many local tribes, especially the Miccosukee, the python invasion felt like punishment. Elders described it as the curse of human arrogance, a sign that people had broken balance with the land. Yet while communities mourned their changing home, television crews and thrill-seekers turned the crisis into entertainment. Airboat tours offered python safaris for tourists, social media filled with photos of people posing beside dead snakes. The tragedy of the Everglades became a sideshow for profit. For scientists and hunters working inside the swamp, the nightmare had physical costs. Biologists performing dissections often contracted leptospirosis, a serious infection spread through swamp water and decaying animal tissue. Several developed chronic respiratory problems after long exposure to the foul gases from rotting carcasses. In 2018, a wildlife handler nearly died when a python bit through his arm and transmitted salmonella directly into his bloodstream. The wound became infected within hours. The medical team said it was one of the most severe bacterial contaminations they had ever seen from a wildlife encounter. By the mid-2010s, the Everglades were almost unrecognizable. Florida's officials knew they were running out of options. Every trap, hunt, and bounty had failed. The snakes kept breeding faster than they could be caught. That realization forced Florida to try an experiment. Before they ever thought of creating robotic rabbits to battle the pythons, they did something entirely crazy and chaotic. The human war, bounties, blood, and the limits of control. The first public battle between humans and Florida's pythons looked more like a spectacle than a rescue mission. By the time the state launched its famous 2013 Python Challenge, panic had already spread through rural communities. The rules were simple. Anyone could join, and cash prizes would go to whoever brought in the most snakes or the longest one. What happened next shocked even the officials who organized it. More than 1,600 people signed up. They came from almost every state, armed with machetes, rifles, and headlamps. For a brief moment, it felt like a war against monsters. But after a month of searching, only 68 snakes were captured. That number was nothing compared to the tens of thousands still breeding deep in the swamp. Despite the poor results, the contests continued. Over the next few years, prize money grew, and professional hunters joined in. By 2019, Florida had spent more than $8 million paying bounties and hiring contractors to patrol the wetlands. Still, surveys showed the python population had increased by about 30%. The harder people fought, the faster the snakes seemed to reproduce. The problem was scale. The Everglades covers more than 1.5 million acres of thick vegetation, mud, and water. The snakes were nearly invisible in it. They blended perfectly into the swamp, hunted at night, and moved silently through miles of grass and reeds. For every one caught, dozens more slipped away to lay eggs. To find new tactics, researchers began implanting tracking devices in captured females. They called them Judas snakes, because the tagged python would lead them to others during breeding season. The plan worked, but the discoveries were grim. In one recorded instance, a single female was found surrounded by nearly 100 eggs, each ready to hatch. The footage looked like something out of a horror film. Another showed a hunter lifting what appeared to be a log, only to reveal a tangle of newborn snakes writhing in the mud. Each egg meant another predator that would grow to 15 feet within a few years. The chaos on the ground grew worse as the hunts expanded. Airboats tore through fragile marshes, crushing young cypress roots and the nests of waiting birds. Trucks left deep ruts that filled with polluted water and pesticide runoff. When carcasses piled up, many were burned in open pits. Scientists later found that the burning released toxic mercury into the air, a result of the snakes consuming contaminated fish and mammals. The effort to fix one problem was quietly creating another. In rural towns near the swamp, the hunts became a strange mix of fear and entertainment. Communities hosted python derbies with food stands and beer tents. Television crews filmed excited amateurs posing beside massive dead snakes. It no longer looked like a conservation effort. It looked like a festival built on destruction. Some residents treated the hunters as folk heroes, while others accused the state of turning a crisis into a game. Churches in southern Florida even held prayer circles, asking God to rid the land of the serpent plague. Behind the excitement were disturbing costs. Many participants suffered from exhaustion and heat stroke after hours in the sun. Others ended up hospitalized with infected bites and deep cuts. Wildlife officers reported nightmares and flashbacks from handling mutilated animals and crawling through dark water at night. Some developed symptoms similar to post-traumatic stress disorder, the same condition often seen in soldiers. The work changed them. One night vision recording from 2015 captured a moment that no one on the team could forget. A hunter waded waist-deep into black water, shining his light on a shape in the reeds. The camera showed a flash of scales before the screen tilted violently. A 17-foot python had coiled around him. His GoPro feed ended in a muffled scream, and only his flashlight was recovered. By the late 2010s, it was clear that the hunts could not stop the invasion. The spectacle had faded, and all that remained was exhaustion, trauma, and the feeling that humans were losing control. When men, guns, and bounties failed, officials decided to turn to something else entirely. And once again, before they turned to rabbits, they decided to rely on instincts older and sharper than their own, the noses of dogs. Canine heroes and the birth of desperation. The first time the state sent dogs into the Everglades, handlers said it felt like walking into a minefield. The swamp was quiet, the air heavy, and the only sound came from the panting of two trained canines named Truman and Eleanor. They were Florida's newest recruits in the war against Burmese pythons. Truman was a black Labrador with calm focus. Eleanor, a Dutch Shepherd, was smaller but faster. Both had been trained for months to recognize the specific scent of a live python. The dogs could detect pythons buried beneath brush, under water pumps, and even deep inside thick sawgrass. Their handlers rewarded them with toys each time they stopped and barked near hidden snakes. The results came fast. Within the first month, the dogs located 4 pythons that had gone completely unnoticed by hunters. One of the most important finds came when Truman alerted near a sugarcane irrigation line. When handlers dug there, they uncovered a breeding pair of pythons guarding more than 20 eggs. That discovery proved what biologists had feared. The snakes were moving out of the Everglades and into farmlands. The early victories made national headlines. News programs called Truman and Eleanor Florida's furriest soldiers. Videos of the dogs proudly sitting beside captured snakes spread online and gave the public hope that the battle was finally turning. But behind the cheerful coverage, field reports painted a darker reality. Handlers often worked in extreme heat, surrounded by sharp reeds and mud that could swallow a person knee-deep. Some days ended with bloodied paws, dehydration, and exhaustion. The dogs wore cooling vests, but the humidity often made those useless. Farm canals were also often contaminated with fertilizers and pesticides. Handlers waded through chemical runoff while keeping their dogs on long leashes. Both humans and animals developed skin irritation and breathing problems after repeated exposure. She detected a snake, barked to alert her team, and ran ahead before the handlers could reach her. They then heard a splash and silence, likely when the python struck and dragged her underwater. After hours of searching, they found only her GPS collar stuck on a branch. Her body was never recovered, and the incident was kept out of official reports to avoid public backlash. Veterinarians who examined injured dogs described the effects of swamp exposure as worse than any training injury. The Everglades water was full of bacteria and acidic peat. When it entered small cuts, it caused infections that ate through the skin. Several dogs developed lesions that would not heal. Some handlers said the smell of infected wounds reminded them of rotting meat. A veterinarian later described it as sweet rot, a scent she said she would never forget. Despite the risks, the program continued for another year. The dogs were the only tool that seemed to work consistently, even if the results came at a cost. But the success could not hide the growing problem. The Everglades were too vast, and the snakes too many. For every python captured with a dog's help, dozens remained hidden. Funding began to run out as treatment costs and equipment repairs mounted. By the time the expansion plan was canceled, the dogs had been retired for health reasons. Truman's coat never recovered from chemical burns, and Eleanor's replacement never matched her tracking ability. The handlers were proud but broken. They had proven that scent detection worked, but it came with pain no one wanted to repeat. But still, Florida wasn't ready to give up. Not yet. And so, it turned its attention to live rabbits. The idea began as a secret field experiment and ended as one of the darkest chapters in Florida's war against the pythons. The moral abyss: when Florida fed the swamp to save it. By the early 2010s, some researchers proposed using live marsh rabbits as bait. On paper, it sounded simple. Pythons were already hunting these animals in the wild. If the rabbits could draw the snakes into monitored zones, hunters could capture them more efficiently. The first trials took place in restricted parts of the Everglades. Scientists built small enclosures along swamp trails and placed live marsh rabbits inside. The pens were fitted with motion cameras and radio sensors so researchers could track activity overnight. For the first few nights, nothing happened. Then the pythons began to arrive. Over the next 3 months, about 20 snakes were captured, but most of the rabbits were killed. The researchers achieved their goal, but the footage was horrifying. The snakes struck fast, crushed the cages, and swallowed the animals alive. Internal memos from 2014, later leaked to the press, revealed that field teams monitored the entire process through radio feeds. The reports described the rabbits' distress calls echoing through headsets as the snakes attacked. One technician wrote that the sound was unbearable, but they were told not to intervene until the python was fully engaged. When that leak surfaced, public reaction was immediate and angry. Animal rights organizations accuse the state of sacrificing one species to save another. The phrase "blood for biodiversity" began trending locally after whistleblowers shared photographs of mutilated bait animals. The environmental effects made the situation even worse. The carcasses that were left behind contaminated water samples and attracted vultures and other scavengers. The smell of decay spread through nearby wetlands and drew feral hogs into the area, adding another invasive species to the problem. Local farmers complained that the experiments turned sections of the swamp into open feeding grounds. Even scientists working on the project admitted privately that they had lost control of the conditions. Religious and community leaders condemned the program. Churches in nearby towns compared the use of live animals as bait to ancient sacrifices. Editorials in major newspapers called the experiments a moral failure. Lawmakers demanded investigations, and the Florida Fish and Wildlife Conservation Commission faced public hearings. Officials insisted that the research was meant to protect the ecosystem, but few people believed it. Photos of terrified rabbits trapped in cages spread faster than any official explanation. Inside the field teams, the emotional toll was severe. Many researchers began having nightmares and described feelings of guilt similar to those seen in combat veterans. Some developed what psychologists later called compassion fatigue, a breakdown caused by constant exposure to suffering. Several left conservation work altogether. One lab technician later admitted that recordings of the rabbit's screams had been so realistic that even captive snakes in laboratory tanks miles away began striking their glass enclosures during playback tests. That incident convinced several staff members to resign immediately. The backlash forced the state to shut down the live bait program within a year. The official reports called it a valuable learning experience, but privately, no one wanted to repeat it. The trials had revealed one undeniable truth. Rabbits, or even the illusion of them, could lure pythons better than any human trap. But the price had been public outrage, scientific shame, and a broken workforce. Still, within that moral disaster lay a clue that engineers could not ignore. If real animals could bring snakes out of hiding, then a mechanical version might do the same without causing harm. From that wreckage of ethics and emotion, a new idea began to take shape. Birth of the robotic rabbit. A small team of engineers and biologists gathered inside a research facility on the edge of the Everglades. Their goal was clear. They needed to design something that could do what no human or animal could. It had to survive the swamp, attract a python, and help capture it without adding more suffering to the ecosystem. That idea became the robotic rabbit. The project began with months of research on how real marsh rabbits behaved. Scientists filmed hundreds of hours of footage and measured their average body heat, heart rate, and movement speed. They learned that pythons hunted by sensing heat rather than sight. To fool them, the decoys needed to radiate warmth exactly like living prey. Engineers installed tiny thermal heaters inside each rabbit's chest cavity. The heat was controlled by a microprocessor that kept the temperature steady at 37 degrees Celsius, the same as a real animal. This was combined with a chemical cartridge that released a light scent identical to rabbit pheromones, a compound that snakes could detect even through layers of mud or grass. The next step was movement. A mechanical skeleton made of lightweight titanium rods allowed the body to shift slightly in the wind. The ears and front paws were powered by micromotors programmed to twitch at irregular intervals, so the rabbit would never seem robotic or repetitive. A small AI camera was mounted in one eye. It operated in infrared mode and could recognize the shape and scale pattern of a Burmese python from several meters away. Once detected, the camera transmitted a signal to a central control hub through a wireless network. That alert gave field teams real-time information about where and when a snake approached. Power was a constant problem. Running in the Everglades meant constant exposure to water, heat, and mud. Engineers solved this by fitting the rabbits with miniature solar panels that recharged lithium-ion batteries beneath a waterproof synthetic fur shell. The fur was made from a silicon-based polymer that resisted rot, fungus, and chemical damage from the swamp. To avoid any chance of pollution, the units were programmed to shut down automatically if they were damaged. This self-lock function prevented leaking batteries or lubricants from seeping into the environment. Once the prototypes were ready, the first field tests began. Dozens of robotic rabbits were placed near canals and old python nesting zones. The goal was to attract breeding females, which could lay up to 100 eggs each season. Within days, the decoys began to draw snakes out of hiding. Cameras captured images of pythons slithering toward the heat signatures. When a snake attacked, the device transmitted an alert, and hunters arrived quickly to capture it. The early results were a breakthrough. Several large pythons were removed in the first few weeks, including egg-bearing females that could have repopulated entire areas. The engineers began to call their inventions mechanical martyrs. Each one sacrificed itself for information that helped refine the next model. But not everyone saw the project as progress. Local residents started spreading unsettling stories. They said the new rabbits carried the spirits of the ones killed during the earlier live bait trials. Some claimed they saw their eyes glow red at night when the units recharged, a sight that frightened people living near the test zones. Indigenous elders refused to enter certain areas, saying the land had been disturbed by machines that pretended to be alive. Despite the fear and superstition, the results were undeniable. For the first time, Florida had created a machine that could outsmart one of the most successful predators on the planet. The robotic rabbits were capturing pythons faster and more efficiently than any human effort before them. Yet, while the state celebrated its small victories, a new question was growing inside the research teams. No one knew how long this advantage would last, or what might happen if the snakes learned to recognize the trick. And just like they had feared, something truly disturbing began to happen. The machines that made monsters. By the middle of the year, something strange began to happen. The number of captures dropped sharply. Cameras showed snakes circling the rabbits instead of striking. Some approached, paused, and then retreated into the grass as if testing the machines. What had started as a success was turning into something that no one understood. Then came the most disturbing event of the entire program. During a night survey, field cameras recorded a large Burmese python attacking and swallowing one of the robotic rabbits. The control team expected the signal from that unit to stop once the decoy was inside the snake, but it kept transmitting for almost 18 hours. When the data was reviewed, the logs showed a continuous pattern of slow, rhythmic pulses, identical to a living heartbeat. This made no sense. The python's own heart rate is weak and irregular after feeding, and the decoy itself had no internal mechanism capable of producing such a pattern. When the team finally located and captured the snake, they performed a full necropsy under supervision. Inside the python's stomach, the robotic rabbit was still intact. Its outer coating was partially melted by digestive fluids. Its lens was cracked, but the power unit was still running. The recorded data proved that the readings had come from inside the snake's body and not from an external interference. Researchers argued for weeks about what the pulses represented. Some believed the sensors were misreading the muscular contractions of the python's digestive system. Others insisted that the equipment had detected something they could not explain, an internal signal that did not match any biological function known in the species. As more footage came in, the abnormalities multiplied. AI analysts studying movement data noticed that pythons were changing how they hunted. Instead of roaming alone, they were forming small clusters in the same areas. The software flagged these behaviors as ambush coordination, a pattern never seen before in solitary snakes. The machines meant to study the predators were now showing evidence that the predators were studying back. Drone surveys confirmed that the snakes were spreading farther than expected. They were found in irrigation tunnels and drainage systems far north of their original territory, well beyond the Everglades climate zone. These tunnels carried water to agricultural fields, and farmers soon began reporting missing calves and chickens again. The expansion meant that the invasion was no longer limited to wetlands. It was moving toward populated areas. Laboratory tests on fecal samples from captured snakes added another concern. Traces of microplastic fibers were found, likely from devoured robotic components. Those fibers were later detected in wading birds that fed on the same fish, proving the contamination was entering the food chain. The human cost of the program soon followed. According to sources, biologists handling decomposed snakes that had swallowed electronics began experiencing tremors, nausea, and mental confusion. Toxicologists found high levels of heavy metals in their blood, the result of exposure to corroded battery materials. Despite all these, the official reports declared the operation an operational success. Government agencies praised the results while ignoring the mounting evidence of change in the ecosystem. Behind closed doors, field notes told a different story. Snakes were returning every night to the same inactive decoys as if waiting for them to reactivate. One leaked email read, "We are feeding the evolution we feared." The robotic rabbits had given scientists more data and faster results than ever before, but they had also changed the behavior of the very creatures they were meant to destroy. By the end of the trial, the Everglades had not been reclaimed. They had been transformed. The machines worked for a time, but in doing so, they taught their enemies how to adapt. Cameras still record movement in the swamps long after every unit has been powered down. The footage shows pythons moving in circles where the decoys once stood, silent and waiting. Florida's invention won battles, but it may have created something worse, a predator that now remembers the machines that once hunted it.